Hello everyone. Today we are going to learn about what really happens inside your body when you get a fever. When you get fever, your body isn't simply getting hotter. Your body actually changes the body's temperature setup. How does the brain's temperature is also changing when you're affected with fever? So let's see. So it starts with infection. మన బాడీని ఎప్పుడైతే బ్యాక్టీరియా ఆర్ వైరస్ ఇన్ఫెక్ట్ చేస్తాయో వైరస్ ఆర్ బ్యాక్టీరియాని ఆర్ ఇమ్యూన్ సిస్టమ్ కన్సిడర్స్ ఇట్ యాజ్ థ్రెట్. వాటిని థ్రెట్లా కన్సిడర్ చేసి ఇన్ఫ్లమేటరీ మీడియేటర్స్ని రిలీజ్ చేస్తుంది. వాట్ ఆర్ దోస్ ఇన్ఫ్లమేటరీ మీడియేటర్స్? దోస్ ఆర్ cytokines. దే ఆర్ IL-1, IL-6 అండ్ TNF alpha. ఈ కెమికల్ మీడియేటర్స్ రిలీజ్ అవుతాయి బాడీలోకి. వన్స్ దిస్ కెమికల్ మీడియేటర్స్ ఆర్ రిలీజ్డ్, think of this as chemical messengers telling the body like there is something wrong, start the defense mechanism. The second, after this, the next procedure is the signal reach this defense mechanism that has to happen. These signals will reach here. These inflammatory signals trigger the pathway that increases the production of molecule called prostaglandin E2. What is prostaglandin E2? So how is it produced inside the body? బాడీలోకి ఎలా వస్తుంది, యూజ్ ఏంటి, అండ్ how is it related to fever? Let's see. So prostaglandin అనేది it is a chemical messenger produced from arachidonic acid. So how is arachidonic acid produced now? Let's see. So మన బాడీ ఎప్పుడైతే ఇన్ఫెక్ట్ అవుతుందో, ఇన్ఫెక్షన్ అయినప్పుడు మన సెల్ మెంబ్రెన్స్లో ఉన్న ఫ్యాట్ సెల్స్ అనేవి అరకిడోనిక్ యాసిడ్గా కన్వర్ట్ అవుతాయి. అరకిడోనిక్ యాసిడ్గా కన్వర్ట్ అయినప్పుడు COX ఎంజైమ్ అనేది అరకిడోనిక్ యాసిడ్ మీద యాక్ట్ చేసి అరకిడోనిక్ యాసిడ్ని PGE₂ కన్వర్ట్ చేస్తుంది. సో వెన్ this converts to PGE₂, there is a response called pain, inflammation and fever. These are different kind of responses that are given to body when the PGE₂ is increased. So all this is COX mechanism. You will get to know that PGE₂ is increased in COX mechanism. So what happens if PGE₂ is increased? When prostaglandin E2 is increased, it acts on hypothalamus. You know hypothalamus, right? It acts on hypothalamus to raise or lower the body's temperature setup. So PGE₂ acts on hypothalamus and the part of your brain that helps regulate body temperature. As you know, hypothalamus is the thermostat of the body. Why is it called thermostat? Because it regulates the complete body temperature. And where is it located? It is located in the brain. Your thermostat gets reset. Normally your hypothalamus maintains your body temperature around its usual temperature, but during fever, when PGE₂ raises that set temperature, fever occurs when the PGE₂ levels have increased. As I said, how prostaglandin is synthesized and how it is increased in the body earlier. Normally, imagine your thermostat normally being set to 37 degrees Celsius. Suddenly, someone changes it to higher temperatures. Your body now thinks, I'm too cold, even though your temperature is actually rising. This is normal temperature, now new set point. So what happens because of this? You get chills. So your body starts trying to reach this new higher point, and your blood vessels in your skin constrict, and you may be shivering because of this, and muscles may also generate more heat because they need to reach to the set temperature, whatever. So next, what happens because of all this? Blood vessels constriction and your metabolism is also increased. All this will lead to increase in the temperature. So That's why you can feel freezing cold while your temperature is going up. Those chills aren't because of your body is losing heat. Your body is actively trying to generate and conserve it. So as a result, your temperature rises. Once your body reaches the new hypothalamic set point, your chills usually settle down and body's temperature is elevated. That's it. And then fever breaks. When the infection and inflammatory signals start coming under control, PGE2 levels decrease. As I said, in the PGE2 levels, increase, they settle down when the when the infection and inflammation signals starts coming under control, the PGE2 levels decrease. The hypothalamic set point moves back to normal, and now your body is higher than new target. So your body needs to lose heat. How does your body lose heat? The heat is produced because of the constriction of the blood vessels and muscles and increase in the metabolism. So in the same way, when the blood vessels dilate, you may sweat profusely, and that's why you suddenly feel hot and sweaty when fever breaks up. And a lot of people might have observed, when you consume a paracetamol, you suddenly profusely start sweating. That's because of that, because rapid reduction in the prostaglandins. Paracetamol reduces fever largely by decreasing prostaglandin mediator signals in the central nervous system, and hypothalamic set points move back towards normal. Your body no longer needs to maintain the higher temperature. And let's see the whole pathway. This is the whole pathway. After infection, the immune activation occurs, and as I said, this is where the complete COX cycle occurs, and PGE2 is increased, and hypothalamic set point. The whole process is here. The hypothalamic set point is set, and this leads to chills and shiver. When the fever is reached, again the PGE2 decreased. So set point returns to normal. How does it return? Because of vasodilation. Okay. The complete pathway is here. Now, why does our body develop fever? Why does our body develop fever? Fever can help slow down the growth of many microbes. It enhances certain immune systems. It helps the body fight infection more effectively and efficiently. How does fever help us? So, fever inhibits the replication of certain pathogens. Because of the heat, the growth is decreased, and this enhances the immune cell function rapidly. And so basically, fever is our friend. And when to be concerned? Seek medical attention if you have fever greater than 3 days, and fever is greater than 39 degrees Celsius in adults and greater than 38 in infants. So all I say is, fever is a regulated change in temperature set point. It's body's mechanism to indicate there is certain infection that has to be. So what are the drugs which decrease PGE2 levels? There must be some drugs to decrease the prostaglandins, right? We discussed about PCM earlier. Not just PCM, there are other drugs too. Like, what are those drugs? These are PCM, NSAIDs, and COX-2 inhibitors. PCM directly decreases the PGE2. And how does NSAIDs decrease? These inhibit the COX enzymes. So as I said earlier, this is the pathway. Once you inhibit the COX enzyme, there is no conversion of arachidonic acid to PGE2. So the PGE2 is generally decreased and the symptoms are decreased. That's why, and that's how NSAIDs work. So, and how does COX inhibitors? These directly inhibit the COX inhibitors like NSAIDs. So these are the examples: celecoxib, adarocoxib, paracoxib. These are the general medications, that is selective COX inhibitors. These are, as I said, PCM directly decreases the prostaglandin E2, and NSAIDs inhibit the COX enzymes, and selective COX inhibitors inhibit the COX directly. Okay. Okay guys, if you found this video interesting, subscribe and do follow for more. Thank you.